Okay, so again, good morning to everyone. So I received your feedback by last Friday, I guess. I was able to go over it last day. And first of all, thanks for providing the feedback. To be honest, it is very helpful and valuable for me. This is like the first time at NMSU that I'm getting the feedback. Previously, I have taught courses like in UCF and in Turkey. But to be honest, I didn't have the chance to go over the feedback and incorporate it into my teaching style. So I have tried to now this time consider it and analyze it and then try to improve myself. Hopefully, it will be beneficial for both me and you, and also for the people who are going to take my lectures or courses in upcoming semesters. So I just want to quickly share with you what I think about your feedback or what are the findings for like overall findings. So the first thing is that, okay, what aspect of teaching is most beneficial to you? You were asked to select one of them. So most of the people think that course material is the one which is helping them. Also instructions and grading, which basically means that the way the assignments or any grading item is designed and what you are expected to do is clearly explained. And also active learning. So basically it is giving me the message that I need to reinforce these things because these are beneficial to most of the people. Like most people think that these are the top three most beneficial things. But then when I look on the other side, with the second question, which was basically what is like, what needs the most enhancement in terms of the teaching style. So here in this graph, lower is better, higher is bad. So here what I see that most of the students are complaining about active learning, which basically means that they have the less chance to interact with me or to be actively engaged during the lecture. So I will try to address that issue in upcoming lectures. And also another thing which requires attention is the interaction among students. So I mean, the first part, active learning, I mean, it is more, I guess, related to me. But the second thing, interaction among students, what I was thinking is, and I need your opinion on this, maybe I can also do a poll on the Canvas page. So, we have 4 projects, right? So, and this was like one of the huge complaint or major suggestion by many students that they want to do the collaboration with other students. So we have 4 projects. One is already gone. Second is going to be released today. So it is too late for the second project to do any changes. But for the remaining 2 projects, what I can do is that we can do the group projects instead of individual projects. But then if even there is a single student who says, no, I don't want to do the group project, I will not change the policy for this course offering at least. Because I don't want to end up in a situation where there are, how to say, unexpected situations where students are complaining that I was unfair to them. Okay, so I will ask at the Canvas, and if no one complains or no one is like disagreeing on having the group projects, then we will go with the group projects. But keep in mind that everything has pros and cons, just like I'm trying to explain in my lectures, everything has trade-offs. So yeah, when you're doing the individual projects, you don't have the chance to collaborate with other students. But then the advantage is that you are evaluated based on your performance. Okay, so everything is in your hand, right? But if you are doing group projects, yes, you can interact with other students, you can meet, you can talk, you can exchange ideas, but then your evaluation will become dependent upon your group partner. Like, for example, let's say if there are three, I'm thinking that we have at least 3% in one group. So let's say there are 3%, and one of them is super active, one of them is a sleeping project partner, and the other one, third one is, let's say, medium level. So the one who is like super active is at a disadvantage, right? Because his performance, the overall score he or she will get will depend upon the other 2%. And the person who is like most lazy in the group will be taking undue benefit, right? So still I can do something to address this issue. Like, for example, I can ask you to do the peer review or give the score to each other, like each members of each group give the scores to the other members. Or I can assign the duties. But then keep in mind that when I do the poll or ask the question, so give answer to that question, keeping in mind all these trade-offs. Okay. And as I said, if there is even a single student who says that he or she is not fine with the group projects, I will not do the group projects because we are in the middle of the semester and I don't want to change the policy in the middle of the semester. Not middle, but we are like 5-6 weeks into the semester. Okay. So okay, so this is just like the graph generated from the results of the third question. So I think the lowest score I'm getting is on my teaching ability, but I hope if I address all those comments which you have made, then hopefully next time this will be better. Okay. Other things I am not much concerned because they are more than 80%, more than 80% score, so it's okay. This is like 78. Okay, so I also went over, I also go through all your responses for question number 3 and question number 5, 6, and 7. So which were like kind of textual feedback instead of like multiple choice questions. So, and I have categorized them into different categories. So let me go through those which can be easily addressed. Comfortability, with someone saying that we have less seating space yet, but this is something which I can't address. Maybe I can ask the department, and in next semester, when next time the course is offered, maybe they can assign a more spacious room. Suggestions for next semester, smaller but frequent. I really like this one, like having frequent projects, smaller projects. But the thing is, again, we are in the middle of the semester and I don't want to change it now. Maybe I can consider it the next time. Someone also said that maybe you should require at least a 50% attendance because as you can see, many of the people are missing. So maybe we can ensure that people are attending at least 50% of the lectures. Okay, availability. I was already recording the lectures, but I think I didn't share the Zoom link with you guys, but today I have shared them. So they are available on the syllabus page. If you want to join online, you can join online. I was uploading the slides, but I was late. I was doing like after the lecture. So I will try to from today to upload them before this lecture starts. Okay, this thing is like more about how I deliver the lecture, my talking style. I will try to address it. More energy, I don't know how how can I get more energy? Maybe I need an energy drink, I don't know. But other than that, I can try to address the other items here. Do I speak like how to say, not louder? Not everyone is able to listen or hear me. After the lecture, to be honest, I am exhausted. I go and take like at least 15-30 minute break after the lecture. So anyway, so now those things which are like more, how to say, more meaningful are which can be like which need extra effort to be addressed. Ask more questions, not to the same students. That's true. I'm asking questions, but maybe I need to increase the frequency and the number of the questions. And then about asking the question to the same students, I also need the cooperation from your side. I want you to be also active so that, I mean, if someone is active, I mean, naturally my eyes go to that person. Or so I want you to be also, even if you have wrong answers, say them. It's okay. You are learning. You are not like you're done with the course. Okay. Even when you are done with the course, you are not expected to know everything. Okay. Quizzes before or before versus after the lecture. So some there was like this. There was a comment, but this was like not a majority opinion. A very small minority opinion that quizzes should be done before the lecture, after the lecture, not before the lecture. But then there were also some students who were saying that they really like that the quiz is before the lecture, so that they have to read the chapter before coming to it. So in this way, they already become a little bit prepared. So I'm not going to change it now again for the same reason that we are in this middle, and I don't want to change the policy, but maybe I can consider it next time, depending upon final feedback or final comment from the students at the end of the course. Group collaboration, I already talked about that. I mean, I will do a poll, and on this that we can possibly we can do the group projects. I will try to do some break time activity for you guys so that the class becomes more lively. Clarity, more code examples, more diagrams, some I think some students really like last time when I draw something on the board. So they want more drawings on the board. And they also want more discussion on sample exams, projects, and make the course understandable for all, not only for the grad students. So I will try to address all of them. Actually, I have prepared a checklist for which I will try to include in every lecture for my own reference. It is not something for you. I will just hide that slide, but I will track it that I have like addressed most of these concerns. Time allocation, spend more time on topics and give less preference on following the schedule. I agree with you on that. But again, I am also limited on time. So yeah, when I prepared the schedule, I said it is tentative. I mean, I would try to follow it, but it is not like written in the stone, which cannot be changed. Actually, if you have observed carefully, I am changing the schedule, tentative schedule, as we are making the progress. So yeah, I will like give more priority to explain topics in full detail, relatively more detail. But at least I think we should be able to cover the core topics of the operating system, if not everything. Okay, so anything from your side on this? Nothing? Okay, so if nothing, then why is it not animated? Okay. Okay. What is happening? Okay, something is wrong, but anyway, with the animation. But anyway, first have a look at this code. You have like 2 minutes. Or you, if you want, I can walk through the code, what it is doing. You have 1 minute, look at this code and try to understand what it's trying to do. If not clear, you can ask if something is not clear in the code. Okay, so maybe I think I can help you on this. So if you anyone who is like who can explain what this code is doing, not you, anyone else, anyone else, be brave. So do you understand what this code is doing? You have this single files. First, you have a definition of a message, set and get my ID. Then you have main method. So what we are trying to do here? Yeah, that's correct. So basically what we are trying to do is it is very similar to the example we had in last lecture. We are trying to create two threads in the for loop, right? So we are creating two threads, and then both of those threads, they are calling the function. Which function? Which is given in the function pointer array. What is the function pointer array? There are two elements, but those both elements point to the same function. Basically, I want both threads to execute the same function, right? And then what I'm doing in this function, I am passing when I invoke the thread. So I am passing it, if you remember, see here, argument for the function. We are passing the ID, right? And ID is what? ID is set to, it is an array with two elements, 1 and 2. So the first thread will get the ID argument of value of 1. The second will get 2. So basically what I'm saying, I want to set the ID of the first thread as 1 and the ID of the second thread as 2. Simple, right? And here I'm simply saying my ID, which is a global variable, I'm setting it to the parameter which is passed in. And then I'm saying, okay, sleep for some time and then print your ID, right? Now, when I run this code, I see this output. My ID is 2, my ID is 2. Both threads are saying my ID is 2. Why both threads are saying my ID is 2?
They're like race conditions since they're both using the same global variable.
Yeah, that's true. So anyone else who want to add to what he said? That's true. Yeah, go ahead.
Basically, one of the variables and its value replaced by the other variable because both were basically running at the same time, and one of them wasn't completed yet.
Yeah, that's true. So here is what is happening. Now, if I draw something on the board, people online or the video camera will be able to record. Anyway, so here is what is happening here. That let's say my ID is global variable, right? And we know these are threads, right? So global variables are stored where? Data segment, which is shared among threads. So both threads, let's say thread T1 and thread T2, both have access to this global variable, right? And now, when I let's say create the first thread and it starts executing the function my ID, so and I'm passing it the ID of 1, so I'm passing just the pointer variable to that. So it is storing the value of 1 into this global variable, right? But then it is put to sleep. So when it is put to sleep, the scheduler schedules and the second thread gets the chance to execute. So when it gets chance to execute, so it goes and it sees what it says. I passed it the ID of 2, so it stores ID of 2 in the my ID variable, global variable, so it becomes 2. And after that, let's say the thread 1 wakes up from the sleep, so it starts executing. So it prints my ID is whatever is the value of this. So this is the value of latest value of this one. 2, and then thread 2, when it also wakes up from the sleep and it executes also print the same things. Okay. So, which is not what we want, right? Because we want both of them to have their own unique IDs. I mean, this is just a toy example. You can, if the kernel is supporting the thread if there is a support for threading at the kernel level, kernel anyway assign the thread's unique ID and you can get it. Here, I'm just trying to convey the point, which is about thread local storage. What is thread local storage and why we need it, okay? So here our objective is that we want our threads to have unique IDs assigned by us. How we can achieve that? Any suggestions on that? Without using kernel level support or without using any API? How can you modify this user level code to ensure that both the threads have their unique ID? You can make any change in this code, whatever you want.
We store the IDs on the set that we have to get generated.
We store IDs what?
We're gonna hash it, put the IDs in, and every time we make a new one, we make sure it's not already there and then assign it to the thread.
So you are saying like having multiple IDs and separated and assigned separately. Okay, yeah, that is one solution. Yes.
So you mentioned we couldn't use, so can we use the pthread API or do we have to come to a solution without it?
No, without it. Actually, pthread API, it provides you an API to get that thread ID, but I don't want to use it. Okay, because that kills the whole point of what I'm trying to explain, the thread local storage. Okay. He said what you can do is that you can have two, let's say, separate IDs. You can say int my ID 1, int my ID 2, right? And then, okay, can anybody tell me, okay, this will work, but what is wrong with his solution? Yes.
At another thread, you'll need another global ID. At another thread, you'll need another, and it goes on. The more threads you need, the more global IDs you have to.
Correct. So you need changes in your code. Let's say you have written the code for your, it is a legacy code which was written for single threaded application, and you are porting it for multiple threads. Now, depending upon the number of threads you have, if you have n threads, you need to have n thread my IDs and my IDs. Okay. So this is it will work, but it is not a nice solution. Okay. So then anything else? Any other idea? Yeah.
So why not move the critical section, which is a function pointer and IDS, into the for loop? Wouldn't it just create a new context in the stack if we do that?
Wait a minute. Say it again.
Yeah, so why not move the void function pointer and IDS into the for loop itself?
Okay.
That way, if I'm thinking correctly, it'll create a new, when the thread gets created, it'll copy it into its new stack, creating its own variation, or creating its own copy of it.
That's true, but how it solves the problem? Because the new function pointer will be created, but our issue is with the global data.
Oh, yes, because it's in my ID.
Yeah.
So why not just move in my ID into main itself? That way, when the thread actually creates its own stack, my ID will then be given a copy that is separate from the actual stack.
Even if my ID is put inside the main, it will still be it will become local only to the main thread. You know, there are 3 threads. One is the main thread and two threads we are creating. Okay, so I don't want too much brainstorming. So what we can do is that actually, I think maybe you're thinking in the right direction. Yeah, like what kind of solution we want, but you just don't know how we can achieve that solution, right? So what you can do is that you can say the same thing which one of your friends said, that you can have multiple copies, but not in the way like he said. Like you can specify just like when you create a variable. So you know what is scope of a variable, right? You know the idea of scope, right? So normally like there are 2 scopes, global scope, local scope, right? You can also introduce a third level or third type of scope, which is called third local scope, which means that you can say that this my ID variable, I don't want it to be global. I want it to be thread local, which means that every thread has its own private copy of this data. So the copy which thread 1 has is not accessible or visible for thread 2, and the copy which thread 2 is not visible, accessible to thread 1, right? So in this way, even if you will run this code, you will see that they get their correct IDs because each of them will operate on their own copy of the my ID. Okay.
Are you referring to using like in GCC, there's a special keyword that you can use. I think it's called atomic that allows you to copy that ID to different threads. They're recommending we do that.
Atomic is something
I know there's a special.
Yeah. I'm going to show it in the next slide. Okay.
Yeah, Exactly.
So how to ensure that both threads do not share my ID? So this is basically the problem, that they are sharing the my ID, right? And what we can do is that we can have, by having the private copies of my ID for both threads or the thread local storage, which is called thread local storage. So for example, in C version 11, there is a qualifier named as thread local, and it actually specifies the scope of the variable. And this scope is known as storage class specifier. It allocates when the thread begins and deallocated when the thread ends, which means that if you put this qualifier before the start of any variable, the scope of that variable will be at the start of the thread and it will continue until the third thread terminates. So no other thread will be able to see that particular variable. So every thread in the system will have its own copy of that same variable. Okay. So each thread has its own instance of the same variable. So here is the small change which we need to make. We need to include a header file, threads.h. This is different from pthreads. It is like the header file required by C11. And here we are qualifying our variable, global variable, with thread local. So actually just consider the situation where we first wrote our code for the single threaded application, and then we are porting it, or we are translating it for the multi-threaded application. So if in the single threaded application, there was a global variable, which is now and the multi-thread version need to be shared among multiple threads. So what we need to do is that we need to make it thread local. Okay. So now if you run this code, you will see the correct output, which is my ID is 1, my ID is 2. Okay. So I said that this thread local qualifier, scope qualifier, is supported in line 11 version of C. So what if a language does not support it? For example, let's say some older version of C, then how we can achieve the same effect?
With an older API or like with just pure C?
With just what?
Like with an older API like pthreads or with just pure C?
No, pthread is an independent library. It is not part of the C language. So you can link it with C when you compile your program, but C11 has native support for the thread local storage.
C99.
So if there is a situation like that, then we can use the libraries, for example, pthread, which provides its own mechanism to support the thread local storage. Even like, for example, the language doesn't have, you can use the library to achieve the same effect. However, the issue with it is like, if you go and you check, there is a function pthread key create in the pthread library. You can use it, but there is a disadvantage from the perspective of the programmer. It is more cumbersome and difficult to understand, and it needs multiple line of codes to be added to achieve the same effect. So it is less user-friendly, but still you can do it. It is not like I mean, if the language doesn't support it, you do that thread local storage. You can do with some extra work. Okay. I'm not going to discuss it because I just want to share with you the concepts and ideas. You know how you can do it in C11, which is fine. And if you are like, let's say, writing code in some other language which doesn't support it, and then you can use the pthread implementation to achieve the same thing. Okay.
But where are we passing the ID to the thread again? On which part of the thread?
Where are we doing what?
Where are we passing the ID to the thread? Is it on the side? Can we spot it?
Yeah. And ID. So IDs is, where is ID? Okay, at the top. So IDs is an array with 2 elements. So here I am calling the function in the third parameter of pthread create, and in the 4th parameter, if you remember, we need to pass the arguments for the function, which is invoked which is executed by the thread. And we need to pass the address of the parameter, not the value of the parameter. So we are just passing the address of that array element, which holds the ID. Okay, so again, let's go over an example. Have a look at this code. I don't want to like throw all of the code at the same time. Simple. Now look at the second part. Done. You have scanned the code. If it's fine if you don't understand everything, but if you get like the 80% what is of the idea, what is it is doing is fine. Okay. So, okay. So now when I run this code, and let's say I run it for the first time, I get this output. X is equal to 1, y is equal to 2, summation is 5, product is 24. Now x is equal to 1, y is equal to is printed by the main thread. You know there are 3 threads, right? First is the main thread, and then it creates 2 more threads. X is equal to 1, y is equal to is printed by the main thread. Summation is 5 is printed by one of the newly created thread, and product is 24 is created by one of the other newly created thread, right? But when I run it the second time, I see this output. X is equal to 1, y is equal to 2, product is 24, summation is 10. Why I'm having 2 different outputs? Can anybody explain?
Because the variables are global, so when one of the threads increments it, they're incremented for the entire program. And then the next one accesses, and then they already increment.
Yeah, that's correct. That's correct. So let me try to explain this for everyone. So you have where is X and Y? Okay, X, Y, and Z. They are global variable. X is 1, Y is 2, Z is 0, right? And they are in the global segment, a data segment. Now, so everyone can access it. So the main thread, before creating the child children thread, it was just X is equal to 1 and Y is equal to 2. And now it creates the thread. Let's say it creates the both thread and the first thread starts running, right? And let's say that assume the situation where the first thread is able to execute the first 2 statements. So what it does is that it increments the X, so it becomes 2, it increments the Y, which becomes 3. And then let's say you are running, there are many threads in the system. The number of threads is larger than the number of cores available. So the thread is kicked out by the scheduler. And in the meantime, the second thread starts executing. So when it starts executing, it comes and what it does is that it is doubling the values. So it becomes 4, it becomes 6, okay? And then it multiplies and prints it. So it prints product is 24. And then when the third one again gets the chance to execute, it comes back and it adds them and it prints that summation is 10. Right? But the issue, what is the issue here? The problem in the previous example or the previous slide was that we didn't want to share the data across the threads. Here we want to share the data across threads, but we want to share in the right way, right? So which basically mean that changes made on the data by one thread should be done only in an atomic way, which basically means that if I am updating the data, until I am not done with the update, no one should be able to access the same shared data. Otherwise, my computation will be incorrect or different from what I'm expecting, right? So how can we solve the problem? here can we make the private copies of the data? No, because we want to share the data. We want thread 2 to see the effect of thread 1, but only after the thread 1 is done with its computation. So let's say thread 1 has updated the data, it has incremented. So when thread 2 comes in, it should be able to see the updated value. So we want the data to be shared. But we don't want thread 2 to see the updates until all of the updates are completed. So both X and Y are updated. Only after that, right? So how we can now address the problem? Yeah, go ahead. Yeah. So we can actually enforce or apply the mutual exclusion, which basically means that only one thread at a time can access the shared data irrespective of what is the amount of the shared data, right? So here we are. So the problem here is that our code is not thread safe. So what is meaning of not being thread safe? So the meaning is that actually the same thing. Let me read this statement. A function is thread safe if it will produce correct results when called by 2 or more threads. That is, its effect is the same regardless of the order or interleaving of the execution, which basically means that, remember we said that our thread 1 was kicked out, and then the thread 2 was scheduled, and then thread 1 came back. So the results produced by thread 1 should not be dependent upon the order of execution of multiple threads. It should be independent of the interleaving order. Okay. Yeah, go ahead.
So thread local storage wouldn't work here because we want to share the results. The thread local storage makes an individual copy.
Yeah.
Uh,
Yeah. That's correct. Okay. So how we can make it thread safe? By ensuring that write access to the shared data is exclusive. If the data is you are accessing, if all the threads are accessing the shared data only for read purpose, it's fine, no issue, because no one is modifying, no issue. But if there is at least one writer thread, then we need to make sure that write access to that data is exclusive, which means that if there is a writer thread, so we need to ensure that at the same time when it is trying to write the data, no other writer thread or no other reader thread should be accessing the same data. Okay. So how can we do it? By just like in terms of pseudocode or in terms of idea, just by getting a lock before he access the shared data, which is X, Y, and Z, and then unlocking or releasing the lock once we are done with all the modifications, including here C printf, because it is accessing Z. It is not updating Z, but it is accessing Z, and we don't want, we cannot put release the lock here, because if we release the lock here, then maybe the other thread will come and modify the Z. And same here. So on all threads which are using the shared data, they need to first acquire the lock or get the lock and then release the lock, right? So in pthread API or pthread library, you have a function which is called pthread mutex or something like that. Okay, so you can go and check that. So you can get it. It is, I think, both mutex lock and mutex unlock. So you can use that to achieve the locking and unlocking effect. Okay, so now let me have here a 10-minute break and then we can come back. Okay. Okay. Break, but I'm still here. So, okay. So just to like, as you were saying that there is not enough interaction among students. So what you can do here is like you have like in first 5 minutes, talk to the person who is sitting next to you for first 2 minutes and tell him or her about yourself. And then switch the role after 2 minutes. So if I'm telling you next time, in next 2 minutes, you are telling me, okay, about yourself. And then in the last 1 minute, try to find something which is common between both of you. Go ahead. Try to find common things among you. Okay. Talk with the person sitting next to you. Don't be shy. Go ahead. Go ahead.
Yeah, no, it's really No, I'll put it. So yeah, so when you're like.
Okay, so guys, how many of you were like talking for the first time with one of your class? For the first time? Okay, 3, 4, okay, it's okay. And okay, so maybe I need to also tell something about myself. based on one of the comment which I got from the feedback, which is not like negative things, but someone said that he knows what students are going through because he himself was recently a student, which is not kind of true. Last time I was a student was in 2019. So, so I mean, but in like last 3.5 years, I was mentoring students during my postdoc, graduate students. So maybe it is coming from there, possibly. If I know, okay, thanks for that positive thing, but I mean, it is coming from there. Okay. So, anything you want to ask about myself?
You say 2019?
I was student last time in 2019.
That's not that long ago.
Yeah, but still it is like 5 years.
Yeah, I mean, other professors haven't gone to school in like a lot longer, pretty sure.
Yeah, that's true. That's true. That's true. Yeah, but I was not totally detached from the students, so yeah. Okay, so then let's get back to the lecture then. Okay, so here I said that if there are multiple threads, then we need to make sure that if a writer thread is going to write the data, then there is no other writer thread or no reader thread accessing the data same time, right? So which means that writer thread needs to use locks. So in this situation where one of the thread can be possibly a writer, does the reader thread also need to use locks or not? Reader threads, the threads which are only reading the data.
Is there no modifier? The lock is to
Okay.
prevent writing, right?
Okay, anyone who differs from this answer?
You want to make sure they only see it at the right point. If they look in before everything's done, that's still a problem. So I think they're looking to be too long.
Yeah, that is correct. That is correct. Here is the situation. Let's say I'm only reading the data, okay? And you are modifying the data, right? I'm not modifying, I'm just reading. And let's say the data which is shared between us is two variables, A and B, right? And I want, if let's say I'm reading, you have modified A and you are in the process of modifying B, but you are not yet done. Now, if I try to read the B at the same time when you are modifying, what value I see depends upon depends upon the timing, like whose instruction first get executed. If my instruction get first executed before his write instruction, I will see the old value of the B. If my instruction get executed after his write instruction, I will see the new value of the B. And as a result, what will happen? That depending upon this timing, every time I will see different result. I'm only reader. I will see different value of B every time, right? Whenever I will. So then it will become, and let's say I am doing some computation on the value that of the B that I have just read. I'm doing some computation. So every time the result of my computation will be different depending upon the value of the B. And if it is different and it is generating some unexpected result, it will be very difficult for you to debug it, why it is giving different output every time, right? So if there are reader threads, but we are sure that there is at least one writer, then which is accessing the same data, so still the reader threads also need to use the locks. Okay. Okay, so we have talked about locking, why it is needed. Actually, the upcoming slides, they are not topic of the chapter 4. I think they are covered in some other chapter later in the sequence, but I just want to introduce you at this point with the locking. But I mean, this is not covered within chapter 4. Okay, so how to implement locking? Any ideas? Like I said that okay, pthread library provides an API, but as a user, I am just calling that API. I am not concerned with how this API is implementing the locking. What are your ideas or guess on how the locking can be implemented? Go ahead.
What if you wait until the last thread finishes?
Yeah, but how can I wait? That's the correct thing, what you are saying. I need to do that, but how? Any ideas?
Those should we reallocate?
You first need to raise hand. There are some students who are raising hand. I intentionally don't want them to answer. You want to say something? You? Yeah. No? I think you want to say something. No? Okay. Okay, go ahead.
Okay, so then how about we just make a system call, so the operating system will lock, and then we can wait. And then we can do the process we need to.
That's correct, but let's try to
Well,
like
how
dip
does it-
deeper.
Doesn't actually do
How the operating system will do it, that's it. You are just saying that give the responsibility to the operating system, but how the operating system achieves that, performs that responsibility. No. Yeah, go ahead.
Do we use a bit to indicate whether certain data is in use or not?
Yeah, you are like kind of on the right track. So here is like a naive implementation of locking. Okay. So let's first look at the first part, top part of the code. By the way, the reference is from my postdoc supervisor, Dr. Jan Solehin, his book. So here you have two functions, lock and unlock. What we can do is like, let's say there is no problem with these functions. They are doing their job. So what we can do is that when we want to acquire the lock, you can just call lock. And when you want to release the lock, you just call unlock. Done. Now let's look into the body. In the lock, what you are doing is that you have some lock variable. Okay. And you provide, when I'm calling this function, I will provide the pointer to that variable. Just like your friend said, you can set some bit. Okay. So what you're doing is you say, okay, check the value of that variable. Dereference that pointer and check the value. If it is equal to 1, so when the value of the variable is set equal to 1, we understand that someone has already acquired the lock. So we cannot do anything. We need to wait. Okay. So if the value of the variable is 1, so then wait until it is released. You are like just spinning in a while loop, right? And if the value of the variable is not 1, then the condition is false. You get out of the while loop, right? And then you set the value of the variable equal to 1, which means that, okay, I'm getting the lock, okay? And to unlock, when you are done, so let's say, keep in mind the same example, X, Y, and Z, okay? So you invoke lock before making any changes on the X, Y, or Z. And when you are done, after that, you invoke unlock. So which is straightforward. You simply set the value of that lock variable equal to 0, right? So which basically is a signal for everyone else who's trying to get the lock that I'm releasing the lock, okay? What is wrong with this? Look at the lock function and tell me what is wrong with this. I want participation for everyone, not from 3-4 students only. Go ahead. I said it's okay if you give the wrong answers. It's okay. Now go ahead.
What if the lock isn't released? Because we have a while that has a log bar equals 1, so it's waiting until it's released, but what if it never releases?
That's correct. Let's say the thread which is calling this unlock, somehow it gets terminated. There is some problem and it gets terminated. Then it is never released. Okay, this is one problem. Anything else? That's correct. Actually, it was not even my mind. Thank you. Yeah. Any other issue? Okay, go ahead.
So I see this is the same thing as polling. So more or less, we're wasting CPU resources because we're waiting to unlock the lock.
That's correct. We are wasting the CPU time, which is a precious resource. And it will just keep spinning, but it is spinning, but it is even for spinning, it is executing the instructions, which is wild, right? So, but not doing any useful work. Okay. So what we can do to avoid that? To avoid the CPU underutilization or wasting the CPU time. Or should I throw the like dice who is going to answer? Go ahead.
Again,
What we can do to avoid the CPU waste or time wastage in this case.
if we could somehow keep the process out of the CPU.
Yeah, but I mean, for example, you can invoke wait, or you can put it into the sleep. So which basically means you are saying, okay, give someone else the chance. What is the problem with that?
How do we know when the process can get back in?
Let's say we know there is a mechanism and we are sure that is a guaranteed to be brought back in, but what is wrong with that?
They can change the other variables. What does really matter?
Say it again.
The lock just won't matter if it's sleeping and other processes are accessing it, and they can just change it even though the first one is locked.
Yeah, but it is waiting, so it cannot change the variable. It can come back and it can look when it is when it wakes up from the sleep. It can check the value of the lock variable. Other can change, yes, but when it comes back, it will see the updated value.
Oh,
Yeah. There will be a context switch, right? You are, let's say you have only one core, simple case. You have two threads. So now you are saying this thread one, put it to sleep or make it wait, and you need to bring the other thread in, right? So you first need to save the state of thread one in memory, which means doing extra work, then bringing back the other one, which means reloading its state into the registers, right? So you are paying extra overhead. It will do, but I mean, it will be not a nice solution, not a performance efficient solution. Okay? Do you get the idea? Remember when you we talked about process control block, or we talked about thread table, right? So when you put a thread to sleep, then you need to move all its thread related information from the registers, let's say program counter, let's say the stack variables, okay, and let's say the stack pointers, not variables, stack pointers and local variables. You need to put everything into the table entry before putting it to the sleep. And then when you select a new ready thread to run on the same CPU, you need to read its value from the thread table entry and put them into the registers. So you need to do extra work, right? So this will waste your time. Okay. You were trying to say something?
So you're saying context switching, is context switching similar to an interrupt in this case? Because you're basically interrupting and then moving data across to preserve it. So that you can later.
It is similar to the interrupt service routine in the sense that when you invoke an interrupt service routine, you also need to save the state of the process or the task which is interrupted. And when you are done with the interrupt service routine, you need to again reload its state and into the register. In that sense, it is, yes, correct. They are similar. But the interrupt is basically it either is coming from an external source or from like internal software interrupt or hardware interrupt. But here, what you are doing is that you are saying voluntarily, you are saying, put me to sleep. But the mechanism is same. Okay. Okay. So we have seen like what is wrong with this, what are the different solutions, what are trades-off, right? But there is another thing which is wrong, which maybe you have not thought about. But if you look at the assembly of this code, maybe you get an idea. Do you understand assembly? Everyone? Okay. So what is wrong with this implementation? I'm still asking the same question because I didn't get the answer what I was looking for. So I got like many other answers which are correct. But the problem which I want to address here is, now here if you look at this, look at first at the C code, we are saying we have single C statement while not var is equal to 1, then keep waiting, right? But when we translate it to the assembly, it becomes this kind of code. Like you have 4 instructions, and one instruction is executed at a time. Now, what is our assumption there? Our assumption there is that a thread can check the value of var in an atomic way, But this is not possible because when I translate it into assembly, I have 4 instructions. I first read the value of the lock var into the R1 register. Then I compare the R1 register value with Z. If it is 0, if it is not 0, then I go back to the lock. And if it is 0, then I set the value equal to 1, right? So the while loop is actually executed in these 2 instructions, right? So which basically means that the while loop is not performed or the condition is not checked in an atomic way. These are 2 different. First, you are loading the data and then you are comparing the data, right? Which means that let's say if I load the data, it will become clear in the next slide. So this is the source of the problem here. And I will try to explain. So which basically means this while loop will not achieve your locking mechanism. Okay, I will explain here. And everyone read the code here or not? It looks like a little bit blackish. So it is the same code which is shown in the previous slide, only for the lock thing. Okay, but since we are in a multi-threaded environment, so the same while loop is, let's say, executed by 2 different threads, right? Thread 1 and thread 0. Let's say that thread 1 is a little bit slow in the sense that it starts execution or somehow it is scheduled a little bit later. So time is progressing downward. Okay, so thread 0 first executes the load instruction. It gets the value of lock var. Let's say that the value of lock variable is 0. Okay, so lock gets the value in R1 and R1 is set to 0. At the next timestamp, the thread 0 compare the value of R1 with 0. Is it branch? Not 0, but it is 0. So it doesn't branch and it moves to the next instruction. But at the same time, thread 1, it also reads the value of lock variable at the same time. Remember, they are executing, we are assuming we have 2 different cores. 2 threads are executing on different cores, not on the same core. Okay, so thread 1 also gets the value of lock var, and it sees that yes, it is, and it puts in the R1, so it gets R1 set equal to 0 in its own core register. Next, it compares it with 0, and it says, okay, it is branch not 0, but it is 0, so it doesn't go back to the lock, right? And it also set it equal to 1, and it is also setting equal to 1. Which should not be the case, which is not what we want, right? So here what is happening, that both threads are entering in the critical section. Both threads are acquiring the lock, which is not what we want, right? And why this is happening? Because we are loading a lock variable in one instruction, we are comparing it in the next instruction, and we are modifying it in the third instruction. We are setting it value equal to 1. But if we have a single instruction which can do all these things, load the variable, compare it value, and then modify it, which is setting it. So like, if I am doing it, mean if it is a single instruction and only one thread can execute it at a time, then we will not have this problem, right? Do you agree with me on this? Because if it is a single instruction and all the 3 operations are performed in an atomic fashion, if I am doing it, you cannot do it. If you are doing it, I cannot do it. So which means that if I am in the critical section, you are not in the critical section, right? So we need an atomic instruction which performs a sequence of load plus modify plus store in one instruction. And on top of that, only one of this atomic instruction from any processor can be executed at a given time. which means that two threads cannot execute this instruction at the same time. Okay. So if we have that, then we can achieve the mutual exclusion. How much more minutes we have? 6 minutes. Let me finish this. Okay. So, but for that, we need the hardware support. We need the architecture which enables this kind of instruction. Okay. So let's say that we have the architectural support. We are assuming. Okay. Let's say we have this instruction available which can do all these things in a one step, and no two threads or no two different cores can execute this instruction at the same time. Okay. So then here is an algorithm where it again is not, looks like it's not very readable. It's okay. People at the last row, can you read? Okay. Okay. So this is the algorithm which guarantees the mutual exclusion between two threads, right? So here is how it works. I will walk you through this using an example. So let's say you have two threads. Okay, maybe you can first have a look at this one. In the lock function, what you are doing is that at the top you have the global variable term, and you have an array interested which has n elements, and n is number of the threads which are like participating in the mutual exclusion. Then you have the lock function. You are passing the ID of the process. You can, instead of process, you can consider thread. Okay. So you have the, I'm not saying thread again and again, but I will say process, but translate it into thread. So you have the process ID, you are passing in the process ID, and then you are like translating it to like other. So if let's say we have two processes, so other will become, if my ID is 0, the other IDs will be 1. If my ID is 1, the other will be 0, 1 minus 1, 0, right? So, and then I check if, then I set the element of the interested equal to 2, that which element corresponding to myself. If my ID is 0, I will say, okay, I'm interested. 0 element is equal to 2. If my ID is 1, I will set second element and index 1 equal to 2. And then turn is equal to process, which is like, I want to say it is my turn. Okay. And then this is the condition. So while turn is equal to process and interested other is equal to true, then keep waiting. If not, then you get the lock, right? So it will become clear from this slide here. So here, let's say you have thread 0, you have thread 1, right? So I set my element thread 0 set its own element equal to true in the interested array. It sets turn equal to 0, and there is no, we are assuming there is no race condition, which basically mean that the two threads execute the while at different times, the while condition. So the thread 0 executes the while, and it says turn is equal to 0, and interested 1 is equal to true. Since interested 1 is false at this time point, because thread 1 has not yet set its element of the interested array equal to true at that time point. So it gets the lock. Okay. So it enters the critical section, and when it releases the lock, what it does is that it sets interested equal to false. Okay. Now the same, you can like go through this code, and you will see that the thread 1 will be able to get the lock only when thread 0 releases the lock. As long as thread 0 doesn't release the lock, thread 1 will have no other option but to wait, right? So, okay, maybe I don't need to go to the next slide. So if you look at this code, spend some time, like 1-2 minutes, and like get yourself familiar with this and then let me know what is wrong with this one. I showed you how it will work for the 2 threads. And we are assuming that we have atomic instruction. So that problem is gone. We have atomic instruction. Let's say I want to use the same algorithm for maintaining mutual exclusion among not 2 threads, between not 2 threads, let's say among n threads. How this will be changed. That's good.
Performing is 2 threads, again, you need to add a condition to the thread while checking statement or to look through every single thread, which could involve a whole number of.
Yes. So here the basic idea is that you always check whether the other is, if I am the thread 0, I check if other thread, the thread 1 is interested or not, right? And so now we are, this is the case only for 2 threads. Let's say there are n threads and I am thread 0. So I need to check whether the other n-1 threads, they are interested or not, which means I need to do a lot of comparisons, right? So which means that the cost of this comparison will increase as I increase the number of threads, which means that this solution is not scalable. Scalable in the sense that the time spent in performing the comparison will continue increasing, and my performance will, the time taken to complete the whole application, which is using this locking mechanism, will start increasing, okay, with number of threads, which is counterintuitive, right? Because what we want, ideally we want that as we increase the number of threads cooperating with each other to perform a task, less and less time should be taken to complete it, right? So this is the problem with this particular approach. These are just like some pointers I wanted to give with you for the, like, maybe so that you have some ideas in advance before we start talking about locking. So, but these are the issues which you need to consider, like what we need atomic instructions, one thing. Even if we have atomic instructions, our locking mechanism, our locking algorithm should be scalable so that it doesn't become counterintuitive, that we should get the more performance with increasing number of threads, not lower performance. Okay. Any questions? So these last slides, which are like about how to implement the locking, they will not be covered in your syllabus in your midterm. So don't worry about that. Okay. But only these last slides about implementation of locking. Everything before it is covered. Okay. Okay, then that's all. See you next week.